Hello. I have explained how you can estimate the intercept and the slope of the regression model from the data, and the formula is derived using the idea of minimizing the sum of squared errors. So that's just the idea, and then based on this idea, the programming has been built. So let's say you apply the methods to the real data. So Californian data about the test score and class size with 420 observations, then this is the result. So using the least squares method, the estimated line goes like this. Do you think it's doing well? I think yes. So the data, the scatter plot is well, it's going through the middle of the dots and looks fine. And the detailed numbers are the slope is estimated to be minus 2.28, which means when the number of students per teacher increases by 1, then the test score decreases by 2.28 points. And the intercept is estimated to be 698.9, which means if the student teacher ratio was 0, then the test score would be this much, which means nothing. Actually, by itself, there is no meaning, no implication at all. But it is important to predict the test score. So when you predict the test score based on student teacher ratio, you have to use this form. So 698.9 is the baseline, and as the student teacher ratio increases by 1, you have to take out 2.28 for each student teacher ratio. So then as a result, the trend is downward sloping and like this. And this is how we estimate the regression model, how we use the regression model. Okay, so then as I said, the slope estimator minus 2.28 is kind of the difference in the conditional expectation as student teacher ratio changes. So as you move to another group of student teacher ratio, so if you group the schools into different student teacher ratio levels, and as you change the student teacher ratio, the conditional expectations changes this much on average, approximately. So, and the intercept has no meaning by itself, but it's important for estimation, for prediction. So intercept itself is not meaningful, but still we need to know that to predict the result. Okay, the intercept interpretation is quite straightforward. And for example, let's try something. Suppose that let's be more specific. Suppose that there is a district in the data in California, excuse me, and in that district, the student-teacher ratio was 19.33, and the observed average test score was 657.8. And let's suppose that now for a while, let's suppose that we do not observe the test score. And without using this test score outcome, let's predict the test score for this district, Antelope in California. So then you may use the estimated slope and intercept, and intercept 698.9 minus slope 2.28 times plug in the observed student teacher ratio. We already have this information. Student teacher ratio is given, and you have to predict test score based on 19.33. So then as a result, test score is predicted to be 654.8. So this prediction does not use the actual test score outcome, right? It is based only on student-teacher ratio and estimated slope and intercept. Of course, in the estimation, we have used this observation, but it's kind of we are not directly using the test score. So now you may compare your prediction result and the actual result, actual outcome. There is a difference of 3. So the actual test score is 3 points higher than your prediction. So that is the error term. It may be your prediction error, or it may be that the school district has something good among the unobserved variables. Maybe outperform the expectation. So anyhow, your residual, your prediction error is 3. And we are going now. I have explained how why we are doing regression model, what we need to do, and how we can estimate and how we interpret. So the ideas are pretty intuitive, straightforward. So now the next topic is we are going to use Stata to use actual data, and I am going to show you how to use Stata and how to obtain the results. So this is the Stata output, and let's see, in the next lecture I'm going to show you how to use Stata. So look forward to that. It will be a totally new world, new chapter. See you then. Bye.